Hi, my name is Jamie Lonberg, and I've created a lesson plan incorporating the classification of elements. It is intended for physical science freshmen. The focus of this lesson is understanding the elements' properties and how they're grouped together. The development of the table illustrates how scientific modeling is important to learning, and with the computerized interactive format, students see what a great tool technology can be for changing and analyzing models. The first state standard I have listed basically describes my last slide. Students will use technological tools in a scientific manner, and the goal is to have students properly use technology to gain knowledge. As you can also see, chemistry standards are the dominant theme in this lesson, mainly that the atom is the basic building block of matter, and it is formed of protons, neutrons, and electrons. An atom's subatomic particles help determine its properties, and this is where the periodic table comes into play. It's a table of elements organized based on these properties. Here we see the technology standards addressed in this lesson, mainly creative thinking, scientific inquiry, the ability to draw conclusions, and a basic understanding of current technologies are what this activity focuses on. My learning objectives are directly linked to the standards I've selected. The student must be able to make a distinction between the subatomic particles of an atom, and they must be able to categorize elements due to physical and chemical properties. And then with this knowledge, the students must organize elements in a periodic table. Prior to the activity, please provide a brief preview of what atoms and elements are comprised of. And I've created a small slideshow, but you may have a better method of introducing these topics in your classroom. Secondly, please organize a small pretend table with some everyday items, and this is just a simple way of practicing classification prior to using the interactive simulation. Make sure your students have instructions to accompany this program, including how to open it, and guidelines or helpful hints that they may need along the way. And use your own discretion here. This activity can be as intuitive as you'd like it to be, or it can be more of a guided tour of the elements. My purpose is more along the lines of self-exploration. And also remember to remove any large posters or posted material regarding the periodic table. You just don't want students copying these charts. You want them. You'll need to download the program to each computer that will be utilized during this activity, and if you plan to have students work together, less computers are necessary. Please have the program ready to go on your own computer as well, so you can walk students through the basics of opening the program, positioning and labeling elements, and analyzing them. Involvement in this exercise begins with an introductory presentation regarding atoms and elements, and when this is complete, each student will go through a simplified organizational task. And after breaking into pairs, the interactive simulation can begin. Students will classify and group elements based on their similarities. Because I have an unusually high number of English language learners, somewhere upwards of 40%, I'm aware adaptations are necessary. I'll ensure that a student who has a higher English proficiency is paired with a student who may be more deficient in this area. And if you have access to pairs, please use them. They're a wonderful resource in my classroom. My special education students will receive tangible information. I will create cards where abridged and pertinent information will be listed for each element. Gifted students will be given an additional list of elements not appearing in this simulation, and they'll need to include these elements in their periodic table. I believe this activity can be modified for middle school through 12th grade, and for higher grade levels, you can just encourage higher order thinking and use this simulation as a review, possibly. You can have students also research the atomic numbers as well, interpret these numbers and list electrons, protons, and neutrons along with the application of the program. You could also have students illustrate models of chosen elements. And additionally, if you're teaching about valence electrons in particular and how they determine an element's properties, you can have your students create electron dot diagrams for 2 to 3 of the elements that they categorize during this process. If needed, please don't be afraid to carry this activity into another class period, and don't compromise their efforts for the sake of pacing. To evaluate my students, I'll assess their periodic tables, and I'm not looking for an absolute reproduction of Mendeleev's table. I want to see thoughtfulness and problem-solving skills represented in their final product. Students will need to create conclusions based on this activity as well, and citing the criteria I've specified. Conceptual questions must also be answered. Here we have a stripped-down version of the introduction I give them regarding matter, atoms, and elements. This is pretty self-explanatory, but I will offer more in-depth instruction during the actual lesson. I try to equate the yummy center of a candy bar to the nucleus of an atom, which is positive because of the protons. I will ask students what it means to be in neutral, and then equate this to a neutron's electric charge. And then comes the ever important electron. I try to help them remember electrons are negative, just like being electrocuted is probably also a pretty negative experience. I want students to see that protons and neutrons are very close in mass, while that little bitty electron is negligible when determining an atom's mass. And this mass is essential to understand, because after we've done a crude classification of elements with this lesson, we'll eventually learn about how today's periodic table is arranged by atomic number. And since we'll be acting as scientists did in the 1800s, we'll base our periodic table on mass. And Mendeleev's organization was based on atomic mass, and the significant amount of mass is found in the nucleus, which is comprised of protons and neutrons. Today, this periodic table is arranged by atomic number, which is the number of protons or electrons an atom has, and students will need to understand the difference. And these slides are just meant to give enough information to finish today's activity. I'll scaffold upon these concepts in the next lesson plan. And this is just a little bit of physical science humor. I liken the mass of a nucleus to something quite immense, and electrons are comparatively very minuscule. Here is where we begin discussion of elements. Elements are comprised of only one type of atom, and I'll give them a few examples and then ask the class for some more. I'll refer students to the periodic table, and as ninth graders, they should be fairly confident with the periodic table. My job now is to help them understand how it's arranged and how you can decipher the available information from it. Then I'll show students groups of different elements in the periodic table. Here we have argon, helium, and neon. We'll talk about the similarities and differences. Then fluorine, chlorine, and bromine and how they're similar. And then finally, some of the transition metals, which they probably are all familiar with. Again, we'll just talk about properties and how these elements are grouped together based on their properties. And lastly, we have a little bit of interaction to do before we move to the computers. I give them a list of common items and have them separate and categorize these based on similarities. And now on to the interactive portion of our lesson plan. I will open the folder where I can find the periodic table, double click, and we can see it open now. So to group elements of like characteristics, you click on an element, drag it down, and then click on a color. This will cause the element's color to change. Note that there's no connection between the color choices available and the actual colors on the periodic table. This is just to help you have a visual reminder of what you've placed in that group. And to decide on which elements are to be grouped together, you study the characteristics. So here's oxygen. It's a colorless, odorless, and tasteless. It promotes combustion and forms compounds readily. So now it's a student's job to come up with a summarization of that to label for the yellow. We're just going to call it a gas that forms compounds. Next, let's pull down another. We've got fluorine. Fluorine is also a gas. Fluorine is the most electronegative and most reactive of all metals. Now, back to oxygen. I didn't see anything in there about being highly reactive, so I'm going to give fluorine a different color. Go ahead and put highly reactive gas. And here we see the screen as it might look after a student has worked on the periodic table for a little bit. And I'm going to show you how to work the Analyze button. This is used to provide feedback regarding the assignment of elements in a group. And it'll give sequencing in a variety of directions here in this position according to atomic weights. The color, let's look at that one first. This allows an easy comparison of the characteristics of each element that has been placed in a group. So let's look at fluorine and chlorine. I called them red, highly reactive gases. Read through. Fluorine is the most electronegative and most reactive. That works. It is a gas. Let's look down at chlorine. It's poisonous, greenish yellow. It's found in compounds often with sodium. Yeah, I'd say that is a gas. It's found in a lot of compounds, so it must be highly reactive. And then I have bromine, which is a liquid. Now I might want to think this because I put reactive gas. So this is an instrumental tool for helping students decide whether or not they've placed it in the right category. Now the sequence analyzer provides elements and atomic weight data correlated to the sequence selected. So I can go left to right, right to left, or top to bottom. Let's look at that one. What you should begin to see is that you have, going down each group, you'll see the same colors listed. Like here I have these three as cyan. Let's look at a different one. Let's look here. We have hydrogen. I didn't color it anything yet, but I should see that the weights continue to increase as I go down. So I must have magnesium in the wrong spot. This was a really important characteristic used by Mendeleev in his original design. Let's just back up. There we go, and students continue to click and drag, try to figure out which ones they're most likely similar to, and color them that particular color. When they're done, they can save their data, or they can print. In this case, I'm going to have students print their data, but I may also ask them to record their results in a table that I mimic from this. So in summary, I've really tried to abbreviate the introduction to the periodic table, and this is because I believe that the simulation is the most important part of this lesson, and the activity is meant to be hands-on. Learning will take place as the students explore the program, and trial and error is ideal with this activity. Please allow enough time in class or during the next class period to discuss their findings. This is a wonderful opportunity for students to collaborate with each other and help each other reach some understanding. I hope you enjoyed my presentation, and please comment or feel free to leave questions if you have any. I appreciate your time and look forward to seeing your videos as well. Thank you.